Lesson 5-10 Practice. Looking at rates of change. Question 1. A store receives 2,000 decks of popular trading cards. The number of decks of cards is a function d of the number of days t since the shipment arrived. Here's a table showing some values of d. Calculate the average rate of change of the following intervals. Day 0 to day 5. In day 5, the dependent value was 1283. We subtract 1283 minus day 0, 2000, and we divide that by the number of years from our number of days from day 0 to day 5. It's 5 days, or 5 minus 0. That's negative 143.4 decks per day. From day 15 to day 20, again 5 days. Day 20 was 338. Minus day 15, its dependent value was 528. That gives us negative 38 decks per day. Question 2. A study was conducted to analyze the effects on deer population in a particular area. Let f be an exponential function that gives the population of deer t years after the study began. If f of t equals a times b to the t power, and the population is increasing, select all statements that must be true. A is the beginning deer population, and that has to be a number greater than 0. You can't have negative deer. B is the factor, and it says the population is increasing, so the factor must be greater than 1. It cannot be less than 1 or a fraction. The average rate of change from year 0 to 5 is greater than the average rate of change from 10 to 15. No, at the beginning from year 0 to 5, it would be very small, and then as it increases from year 10 to 15, it would be large. So the average rate of change from 0 to 5 is less than the average rate of change from year 10 to 15. Question 3. Function f models the population in thousands of a city 2 years after 1930. The average rate of change from t equals 0 to 70 is approximately 14,000 people per year. Okay, so that's from the year 1930 plus 70 is the year 2000. So they're saying this amount of change between those 70 years is about 14,000 people per year. Is this a good way to describe the population change of the city over that time period? Complete the following to explain. No, it is not. Near 1930, the average rate of change was much. Okay, so if you look, it barely goes up from 1930 to 1940, right? But from what is this, 1990 to 2000, it goes up a lot. So the average rate of change was less than 14,000 per year. Approaching the year 2000, the average rate of change was much greater than 14,000 per year. Question 4. The function f gives the number of copies a book has sold W weeks after it was published. The equation f of w equals 500 times 2 to the w defines this function. Select all domains for which the average rate of change could be a good measure for the number of books sold. Well, they just talked about this. They said if it was a large number of years, in this case weeks, between weeks 0 and 10, the average rate of change wouldn't describe this average rate of change between weeks 0 and 2 would be very small, where this average rate of change between weeks 5 and 7 would be much larger than the whole average rate of change between weeks 0 and 10. So these are the two answers. They even described it in the previous question. Let's go back and look at it real quick. They said it was much less at the beginning and it was much greater at the end. So it was not. Question 5. The graph shows a bacteria population decreasing exponentially over time. The equation P equals 100 million times 2/3 to the H power gives the size of a second population of bacteria, where H is the number of hours since it was measured. At 100 million, which bacterial population decays more quickly? All right, I'd like to show you, so I'll type in this equation, and I'll type in this equation for the graph. All right, I typed in the equation of the second population, and I typed in an equation for the graph, which begins at 250 million, and then 150 million divided by 250 million gives me a decay factor of 3/5. Because they're both decaying, going down, I need to change the range to be 250 million. And you can see that the green one is going down much quicker as it catches up to the, it starts above and goes down and catches up to the other graph. So the green one's going down much quicker. That's the graph. Okay, which one decays more quickly? The first population. The population in the blank has a decay factor of 3/5. That's the graph. Since it decreases from 250 to 150 million in 1 hour, the blank population decreases by a factor of 2/3 each hour. That's the second population. Since 3/5 is less than 2/3, the blank population, the first one, decays more quickly. That's the green one from the graph. Question 6. A moth population P is modeled by the equation 500,000 times 1/2 to the W power, where W is the number of weeks since the population was first measured. What was the moth population when it was first measured? All right, that would be A, which is 500,000, the beginning population. What was the moth population after 1 week, after 1.5 weeks? All right, we're going to take the beginning population, 500,000, and multiply that by 1/2 times the number of weeks. 1/2 to the number of weeks power, which they wanted to know, which was 1. That'd be 250,000 moths. And what about after 1.5 weeks? Wow. Round to the nearest 1,000. That'd be 177,000 The 6,776 would round up. 177,000. Which graph correctly shows the population? Alright, which one shows 250,000 after 1 week? After 1 week, that's 500,000. After 1 week, that's 250. That's graph B. Does the population fall below 10,000 after 3.5 weeks? 3.5. Nope. That's 44,000. 5.5. Well, it's not below 10,000 yet, but after it would be. They should have said after 6 weeks. 5.5. Question 7. Which value for R indicates that a line of best fit has a positive slope and models the data well? Well, if R equals 0, it does not model the data well. If R equals 1 or negative 1, it models the data well. If it has a positive slope, it's 1. If it's negative slope, it's negative 1. So it has to be positive, so the answer has to be C or D, and the number that's closer to 1 is 0.9. Question 8. The size of a district and the number of parks in it have a weak positive relationship. Complete the following to explain what it means to have a weak positive relationship in this context. Well, if it is weak, the number is close to 0, and if it's positive, it's increasing. A weak relationship means that the line of best fit for the relationship between the size of a district and the number of parks in the district is blank. Does not produce good estimates of the actual data. The positive relationship means the number of parks are increasing as the size of the district increases. Question 9. Here's a graph of Han's distance from home as he drives. Complete the following to identify the intercepts of the graph and explain what they mean in terms of Han's distance from home. All right, the y-intercept is 10. That's the distance in miles from home. And the x-intercept is 10. That's the time in minutes. Complete the following to identify the intercepts of the graph and explain what they mean in terms of Han's distance from home. The y-intercept is blank. The y-intercept is 0, 10. Write 0 of 10. It represents Han being 10 miles from home when he started. The x-intercept is blank. The x-intercept is 10, 0. Write 10, up or down 0, which represents the time it took Han to get home.